right, so today is Wednesday, December 11th, 12/11/2019. We are on lesson 6-7, solve harder exponential equations. Who wants to read our objective today? Can you please stop, Leo? Thank you. Anna.
Solve difficult exponential equations using the rules of exponents.
There it is. So it's very, very similar to what we were doing yesterday. Let's try our first example. You guys actually know how to do all of these, so I'm going to walk through it nice and slow with you guys. These both need to have the same base. Once they have the same base, I can set their powers equal to one another. And if everyone can please shut their laptops and also have all AirPods and headphones removed from their ears, that would be lovely. All right, Leo, you're just going to wait in the hallway for now. Thank you, Leo. I'll talk to you in maybe 5 minutes. I'll leave your AirPods in here, please. Your wireless headphones, Leo, please leave them in here. All right, quiet raised hand. How do I rewrite that left-hand side? Beverly.
It'd be 3 to the third.
3 to the power of 3 and all that to the power of?
4x minus 7.
There it is, 4x minus 7. Thank you. What about the right-hand side? Who can rewrite that for us? Who has their card? Ellery?
We would have 3 to the fourth parentheses 2x.
Perfect. Just rewriting those as higher powers. I can zoom in here so we can see a little bit better.
That's 3 to the power of 3.
It is indeed 3 to the power of 3 on the left-hand side, 3 to the power of 4 on the right-hand side. All right, now I have a power to the power on both sides. I need quiet raised hands for the left and then another one for the right. First, the left. I have the same 3 people that have already participated. I need more people. I have a power to the power. What operation do I do? And then please help me do it. Colby. Multiply. So I'm going to multiply that 3 into these two. Please help me do that.
12x minus 21.
12x minus 21. Thank you. What about the right-hand side? Who can do the multiplication there for us, please? Once we hit a limit of 2 participations, then we can kind of switch to other people. Aurelio? Yeah.
Is it 36x plus 9?
Close. You're going to multiply 4 times 2.
Oh,
8x, and then the next one's going to be, there it is, yeah, thank you. All right, now that I have the same base, I can set their powers equal to one another. Who can read off that new equation for us, please? Beverly?
12x minus 21 equals 8x plus 12.
There it is. Thank you. And then from here, it's just an Algebra 1 problem. Quiet raised hand to walk us through the rest of this entire problem. Ellery?
So you would first add 21 on both sides. So you're going to have 12x is equal to 8x plus 33.
Okay.
Then you'll subtract. Do you want me to keep going?
Keep going, yes, please.
Great. Then you'll subtract 8x from both sides, which leaves you with 4x is equal to 33. And then you divide both sides by 4.
Yep.
So you have that x
Bless you.
is equal to 33 fourths.
There it is. Thank you. It's the same procedure as yesterday. Make sure you have the same bases. Once you get the same bases, set their powers equal to one another and then solve. Ask me questions. Please. I want to clarify your understanding, Lorea.
How did you go from 4x equals 33 to 8?
So, yeah, I didn't show my work. While Ellery did tell us what to do, you're dividing both sides by 4 in order to get rid of the 4, and I'm just left with x isolated. Yeah, thank you for the question. Other questions? Then we're moving on to example number 2. Again, we need to have the same base. Now, this time we have fractions, so it's a little bit scary, but we can do this. I need someone to rewrite the left-hand side still as a fraction, but now with a power.
What?
Anna, have you participated twice already?
No.
All right, go for it.
So it would be 5 to the negative, or 5 to the fifth, but then you just turn it into 5 to the negative fifth.
I think you were saying it correct, and then you kind of switched over, not to the fifth power, but to
Oh,
the
squared.
yes, yeah.
What I was thinking.
So you said both those steps correct. I'm just going to do your first step for now. You are totally correct that it is going to be 5 to the negative 2. This is 1 over 5 to the power of 2. I just want to show all the steps to make sure we don't lose anyone. 3 minus x. Perfect. What about the right-hand side? This can be turned into what fraction? Once you have participated twice, I'm going to start cold calling on other people. So Beverly, you've been in twice. Anna's in twice. Ellery's now in twice. Colby and Aurelio are in once, and no one else has participated. Ellery, or sorry, not Ellery. Emily. Starts with an E. My bad. 5 to the power of... You had it right. You were just saying it. Yeah, 5 to the power of 3. There it is. 5 to the power of 3. All this to the power of 2x plus 5. Thank you. And I'll take your card as well. Next step is to get rid of the fractions by making these negative powers. Who can do that for us? Very, very similar to our warm-up problem. I'm going to cold call on someone that has not participated then. Chewy, you're up. How do I get rid of a fraction? It's going to be...
Divided. Sorry, you multiply by 3.
You don't multiply by 3. So this is now going to be 5 to some power that has a 2 in it. But I have to do what with that power?
Divided.
Not quite. It was positive down here. And on the, when it's switching sides to the numerator, it's now going to be...
Negative.
Exactly. 5 to the negative 2. Thank you, Chewy. This is going to be to the power of 3 minus x. Again, whenever I switch between... Can you please do that after the lesson while you're working on the homework? Instead of having a fraction, I get rid of the fraction by making this a negative power. Same thing on the right-hand side. Who can do that for us? Again, I need... Yeah, Oscar.
5 to the power of negative 5.
Oop. Negative 5 like that?
Yeah.
Careful there. This was a 3.
Man, okay. That looks like a 5.
I can come back and rewrite that a little bit neater. 5 to the power of 3. Is that better?
Yeah.
All right. So it's 5 to the power of...
3.
Oh, new one is...
Power of negative 3.
Negative 3. Perfect. And I can write that a little bit bigger. And that's still all to the power of 2x plus 5. Thank you. All right. Very similar to example number 1. What am I going to do when I have a power to a power, Larea?
How do you get your fraction to the...
So it's one of the rules of exponents, and it states if I have 1 over x to the power of n, I can turn that into x to the power of negative n. It's just one of the rules that we're supposed to know. So applying the rule, that means 1 over 5 to the power of 2 is equal to 5 to the power of negative 2. Just kind of filling in 5 for x and 2 for n. Yeah. Chewy, yeah, go for it.
So it would be 3 minus x.
Yep, that 3 minus x is going to be multiplied by that negative 2.
Also would be negative 5.
Let's do the negative 2 times 3 first.
So negative 5. Wouldn't it be?
2 times 3.
6, Chewy.
Holy crap, dude, I was adding. I'm so sorry.
Negative 5, you're good. And then negative 2 times negative x
I don't
is...
even do it anymore. I'm so
You got this. Negative 2 times negative x.
It's negative 6.
Negative six.
You got it wrong too. It's just
I did.
Hey, I caught that.
Yeah, log it. And
Would it be negative, sorry, positive 2x?
2x. There it is. You can both log it.
I only have one. Chill out.
All 3 of you can log it, sure.
You have 2, really.
Wait, who got that?
Anyone that caught it.
I also found
I
it.
caught it, but
Oh, Colby,
I told
Aurelio, and Beverly.
I definitely caught that.
And Jane too, yeah?
I mean, I'll take it.
Dude, I caught that.
If you caught it, you get it. Ellery's just trying to keep track of the XP.
Oh, I'll take XP.
So,
I can cite it right after the lesson. What about the right-hand side?
I have 3, but I never logged them, so.
Okay, just put the date for now for teacher error. The right hand side, Sam. Yes.
5 to the power of -6x minus 15.
Thank you. You are indeed correct. And next step, what do I do? Sorry, Beverly. You can probably finish. So all the people that have participated twice, you're gonna hold off. You're gonna be my backups, but try doing example 2 and example 3 on your own. And if not, I'm here as your safety net.
Oh yeah, sure that big pop up.
All right. Again, I'm going to cold call on someone if someone does not raise their hand that has participated less than twice. Again, if you participated only once, you can raise your hand again. Choose now in twice. Yeah, Sam.
Do you have to make them equal to each other?
Yeah. So tell me what to write.
-6 plus 2x equals -6 minus 15.
Perfect. Yes, thank you, Sam. Sam is now in twice. I now need to do the solving of this equation. We'll just take one volunteer to solve all of this for us, please. Easy XP here. Solving this Algebra 1 equation. All right, who am I going to cold call on? I only have a few choices now. Cheyenne. Yep. Move it to the right. So what am I going to do to both sides? All right, add 6 to both sides, add 6 to both sides. And that means I have 2x is equal to -6x. And then what is -15 plus 6, Cheyenne? -9. Perfect. We can give it to another person. Quiet raised hand. Who wants to give it a shot? Yes, Jaden. Sorry, you haven't participated yet, so I'm cold calling on you.
I don't even know where we're at.
We are at 2x is equal to -6x minus 9. I need to get all the x's on the left-hand side. Thank you, Cheyenne.
So we're gonna plus 6x?
We are indeed going to add 6x to both sides. Read me my new equation, please.
8x take away 9.
8x, don't forget your...
Now equals -9. Right?
There it is. 8x equals -9. And our final volunteer, easy XP, Adzuri.
Divide
Therefore, your answer is x is equal to -9/8. Perfect, thank you. In our final example, for the notes, we have a division problem instead of a multiplication problem. Oh, we haven't had a multiplication problem. Example number 3, I need to get all of these in the same base. It looks like I could maybe use 16. 4 to the power of 2 is 16. But unfortunately, 4 to no power, that's a whole number, gets to 32. So I'm going to have to change every single term into a base of 2.
He's giving me a pencil. It's okay.
Wait,
Okay.
No kind.
can't you make them all to a base of 4?
4 to what power is 32?
Oh.
That's the problem, yeah.
I did 4 times 4 times 2. Dang it.
All right, so I'm going to rewrite this now as 2 to some power that someone's going to have to tell me to the power of 3 minus 2x.
What'd you say?
Sorry, that was me. I'm gonna admit that was me.
Thank you for admitting that it was you. I'll do it later. Okay, and then on the denominator, I have 2 to the power of something, and then I'm going to rewrite this -6x plus 2, and that's going to be equal to 2 to the power of something to the power of 3x plus 1. I need 3 different hands here, 3 different volunteers at Zuri.
To the power of 5.
To the power of 5, perfect. And I'll get another one. Thank you. What about the bottom? Easy, Emily.
To the power of 2.
Thank you. And then the right-hand side, power of quiet raised hand. Quiet raised hand, who's got it? I have just a few people left to cold call on. I think only one person left to cold call on. Have you participated once or twice? Once. Colby?
I-
4. There it is.
What?
No.
You both have participated once, so it's got to equal at that point. All right, so I now need to do a rule of exponent to somehow combine 5 and 3 minus 2x. I need to figure out what operation to do when I have a power to a power. Another quiet raised hand. What am I going to write? I'll give you a hint. The base is 2. 2 to some power. There's only one person I can call on. Oh, it looks like Loretta, yeah. Careful. 5 times 3.
Okay, 5 times what?
5 times 3. 15, and then I needed to do 5 times the negative 2. Or negative 2x. Negative 10x, yeah, thank you. All right, another quiet raised hand. The denominator, what am I going to be doing? Yes, Brian. I'm going to distribute this 2 into both these terms. So what is 2 times negative 6x? Brian, you got this? Negative 12x, and good. 2 times 2, Brian, still? There it is, thank you. So 12x plus 4. And what about the right-hand side? I'm going to open this up to everyone again because now everyone is in at least once. Beverly.
3 to the power of 12x plus 4.
There it is. Nice. All right. This next step is going to be tricky. Who wants to give it a shot? And again, I'm opening it up to the whole class. I am dividing something with the same base. Ellery.
So you keep the base the same. So then you're going to have negative 10x minus negative 12x. And because 2 negatives make up positive, you will have 2, right? Because you have minus 12.
So you're correct that you're subtracting. Can I show it in a different way?
Yeah.
So you have your original numerator, and I'm going to subtract the denominator's exponent. And then you can help us simplify in a sec. So I have the original 15 minus 10x. That was the top. I'm going to put that in parentheses. And I'm going to subtract, in parentheses, the bottom, the denominator, negative 12x plus 4. And the right-hand side is still the same, 2 to the power of 12x plus 4. Okay, now can you help us simplify by distributing that negative first and then combining like terms?
Yeah. So you'll distribute the negative, so 12x becomes positive and 4 becomes negative.
Perfect.
So you will be left with 2 to the 2x plus 11.
There it is. And the right-hand side is still the same, 2 to the power of 12x plus 4. Again, I'm going to repeat that because I think I lost about 5 or more of you. We are dividing in this yellow step. We are dividing bases that are the same, which means in terms of your rules of exponents, I'm going to subtract. You're going to do the top minus the bottom. That's what I'm saying here. Top in green minus the bottom. But because I have a minus sign, I need to distribute that minus sign into both of these two terms. That's what I did in black here. I made this plus, I'm distributing it. This negative turns into a positive, this positive turns into a negative. 15 and negative 4 makes 11. Negative 10x and 12x makes a positive 2x. And we're really, really close to finishing. We can come up here to the top right. What is my next step? Anyone? Anna?
Set the two exponents to each other.
Perfect. Next, quiet raised hand. What do I do? Beverly.
You're going to subtract 2 on both sides. 2x.
Minus 2x on both sides. And our new equation is?
11 equals 10x plus 4.
Quiet raised hand. Next step after this is to do what? Ellery.
You subtract 4 on both sides.
And I get 10x on the left. What do I have on the left-hand side? Or sorry, right-hand side is 10x. Left-hand side is?
It's equal to 7.
Perfect. And my final step, my last step for our entire semester of notes.
Finally.
That's getting a little bit mean, but Beverly.
Divide 10
And I get x is equal to 7 over 10. Beautiful. We are done with notes for this entire quarter, this entire semester. And tomorrow we're going to start reviewing for the final, but that's it for the notes, which means you are now going to be moving on to Khan Academy. You have one assignment for tonight.